It's 2018. 1 year has passed since our space odyssey has begun, with our 3 astronauts and our group of mice.
Golly gee whiz, my eyes feel weird.
Oh, that's rough, man.
That's messed up.
Forget those eyes. Look at my hands.
That's weird.
I just miss my family.
We got no problem.
Yeah, what's wrong with them?
The problem we are addressing is the negative effects of microgravity on astronauts. All astronauts are affected by microgravity. These effects include muscle atrophy, loss of bone density, and damage to the eye tissue. According to Space.com, a study on 300 American astronauts, 30% showed vision problems in the first 2 weeks of space. For long-term flights, it's 60%, with most of the effects being permanent.
Astronauts lose 1.5% of their bone density per month. Compare that to the elderly who lose 1.5% of their bone density per year. This
All
makes
groups in session morning 11 report to the upstairs hallway to Q. I repeat, all groups in session morning 11 report to the upstairs hallway to Q. Thank you.
This makes their brains brittle. This is dangerous because it'll make them too weak to handle the problems in space, and it will give them a hard time adjusting to Earth's gravity.
Astronauts lose 40% or more of their muscle mass after 6 months in space. This affects their strength and endurance, especially in their legs, making them weak and tired. One example is Scott Kelly, who took a lot of physical therapy to walk again after being in space for almost a year.
We found a cool study about a group of mice in space that stayed in the ISS for 35 days. In this study, there were 2 groups of mice. One group were in a centrifuge which removed 1 g of gravity, while the others were floating around in 0 g. The ones that were in the centrifuge had less damage to their eye tissue than the ones that were in 0 g.
We did a lot of research using the NASA website, Space.com, and Popular Mechanics. We also asked for advice from astronauts and professionals like Mr. Jeff Shire, an engineering director at GE Aviation Systems in Virginia. We emailed astronauts Colonel Morgan and Lieutenant Colonel Ann McClain, in which they told us to send a video of our project to them. Right now they are currently in Russia getting ready to fly to the ISS next month and in June.
Through research, we have found that a centrifuge can solve these problems. In 2011, NASA designed the Nautilus X, a space exploration concept equipped with a centrifuge. In 2004, they designed a short-radius centrifuge to show the effects microgravity has on humans. There are currently 18 centrifuges in use, but none of them are in space. And this is how we came up with our project idea.
The Astrofuge! This is a scale model of the Astrofuge. It is an 8-meter
Just
in
your
diameter.
last reminder, all groups in session morning 11, please report to the upstairs hallway to Q. Thank you.
It's an 8-meter in diameter spinning circle in a 9-meter diameter spaceship. It is surrounded by rollers and powered by a bicycle. When not in use, to help save space, you can actually walk through the Astrofuge.
The Astrofuge is an 8-meter diameter centrifuge that we will use to simulate gravity inside of our spaceship. In the absence of Earth's gravity, we will have to simulate our own. To calculate centrifugal acceleration, or our simulated gravity, we will need to do the equation angular speed squared multiplied by the radius. We can use algebra to derive this equation to an equation that will give us the amount of rotations per minute needed to produce 1 g of artificial gravity, or 1 Earth's gravity. Using this equation, we get that we need to spin our centrifuge at 15 rotations per minute to get 1 g of artificial gravity.
A cool thing about Astrofuge is that it's powered by a bicycle. While one astronaut is getting the simulated gravity, the other is getting exercise. To turn the centrifuge, the astronaut will have to cycle at a pace of 70 revolutions per minute, or RPMs. And for the centrifuge to generate 1 Earth's gravity, it will have to spin 15 times in a minute. To do this, we will have to use torque multiplier gears, such as a worm gear which is used in our robot. We had mechanical engineering professor Dr. Garrett Clayton from Villanova University come to one of our practices, and he helped us design our centrifuge.
The Astrofuge will be installed crosswise in the spaceship to conserve space. Virtual reality will be used for the astronauts to combat dizziness. It can also be programmed to be interactive.
Now,
Now our astronauts can see better, stay strong, and be happy.
Thanks to
The astrofuge.
Very good.
Do you guys have any questions?
Yeah, so clarifying questions. So somebody has to be powering the, somebody has to be powering the centrifuge with the bike for it to be working, correct?
Correct.
And have like the muscle atrophy and things like that. Do you know how much time they need to spend not in space gravity but in Earth gravity in order to combat some of those issues?
The astronaut will have to be in the centrifuge for approximately 1 hour to get the feel of every other day, or 3 times a week, to get the feel of water G.
And do we know if that actually will help?
Yes.
Or is that
Well-
just like a theory?
Well, we know that will help because many studies have been done, and it shows that, and in addition, just sitting in the centrifuge will help combat the vision loss, but it will not just help the bone loss and muscle mass loss. You'll have to exercise inside of the centrifuge to do that, like lifting weights.
I understand.
I think I'm good. We gotta go. That was good.
Anything else you'd like to add?
Well, another cool thing about our bike, the astronaut, you can use a torque multiplier. We can use a torque multiplier for the bike, so that if there's one really big, strong astronaut, and then after that comes like a smaller astronaut, the astronaut can have more power to actually power the centrifuge by using a torque multiplier.
What's the torque multiplier?
So it gives more strength instead of speed, basically.
Yep.
And our centrifuge, our astrofuge, we also use virtual reality, so that helps combat claustrophobia with the astronauts. So instead of being in seeing the space station and the wires, they could possibly see a beach or a vision that they like.
With the VR.
Yes.
Gotcha. Okay, and that's existing VR technology, right?
Yes, so
Yes.
it will not cost anything.
Well, it costs
For
VR.
the program.
Yeah.
All right, great. Thank you all so much. Good luck with the rest of your day.
Thank you.